Okay, I wanna go back to lecture 1. Let's do a slideshow. Okay, so we saw all these diagrams and modeling, and then we came to. This is annoying here. We came to this slide here, the waterfall model. And the basic idea of the waterfall model is that we don't move upstream, which means that when we're designing a piece of software, we figure out how we want to do it, and we figure out everything, and then we sort of travel down the waterfall, and we can't swim back up. So that means we're not going to go revisit what we decided to do, how we're going to do it. We already came up with the whole plan, and now we're going to do it. And it may take us 2 years to do it, and we're not going to reinvest. And this is, we said, this is useful for things like the Department of Defense, because then they know what they're getting. They can hire a contractor, they can hire a software company, and they know what they're going to get.
What's that?
This is, I don't know, it's pretty far down. I skipped. I skipped.
Okay.
Down. It's way down. Where search for waterfall, or don't search. I don't know. Anyway, that's the idea of waterfall, and then there's this picture here. This picture is waterfall, which is saying like this: define what you want to do, then build it, then release, and then you finally get something of value. And in other words, your software is ready at the end, right? You see that? Design, you define what you're going to do, then build it, and then sell it, or then give it to the client. And then you have something of value. And this red line means that your risk goes up if you want to change something. In other words, if you want to try to change something at the end here, it's kind of too late. Now, the idea of Agile is that you define, build, release in small segments. Define, build, release, define, build, release. So you're always having the ability to reassess things because you're only producing a small quantity of code each time. So we use iterations and redesign all the time in Agile. And we talked about there being a Scrum meeting in the morning, and you say, like, in the next 2 weeks, we're going to get this and this done, and we're going to release it. So you kind of have to figure out what your mile markers are going to be. In other words, what you're going to get done by here, what you're going to plan on getting done by here. In other words, and each time it's going to be a release of something. And then the customer can see if what you've done so far is what he expected. And if it's not, you can stop right now and redo things. So you don't wait till the end to find out we did something completely different from where you wanted. Okay, that's all I wanted to show you about from there. Now I want to go back to, I just wanted to remind you about this waterfall and there's Agile. The waterfall is really that Mismach Yazum that we did, that initiation document. Is defining everything ahead of time. Now, where were we? Oh, no, not this one. I don't understand how to. Okay. Hide. Here, Agile. Okay. View, slideshow. So now we're going to talk more about Agile. Agile software engineering. Software product must be brought to the market quickly, so rapid software development. 2.
Software.
Ian Somerville. This is one called Agile Software Development. It's 2 in the folder of software products.
Oh, we haven't done it yet.
This is new. I tried to show you the old slide that we already talked about, just to refresh your memory. And now we're into more detail about Agile. So what is a software product? A software product is like the difference between a custom sewn shirt, like if you go to a tailor and have them make a shirt for you, that's the way it used to be done 150 years ago. And then 150 years ago, in New York, I think, they decided, why don't we just make a whole lot of shirts of standard sizes and keep them on the rack and people will buy them when they want them. And that was actually only after the sewing machine was invented, because it would only be profitable to do that if you have a sewing machine. If you sew by hand, you don't want to do it unless you have a client. So a shirt became a product, which meant you have like a rack, a whole pile of them, and you just buy one you want. And you don't know when you're making the shirt, you don't know who it's for. So software went through the same two stages. It used to be that you hire a company to make your software. But nowadays, there's a lot of times, and we still have that in big companies. But in a lot of times, software is a product. That's why this book is called Software Products. So using software as just an off-the-rack kind of thing. So that's why we say all software products are used pretty much using Agile approach. In other words, the Mismach Yazum is for software as a custom-made software. The initiation document. But you could also have an initiation document in an Agile system because you want to decide if you're going to make your thing at all. Agile software engineering focuses on delivering functionality quickly. In other words, we want to get them something already that's useful in a short period of time, as opposed to telling them, wait 2 years before you see anything that you can use. Responding to changing product specification and minimizing development overheads. Now, getting something out there and being able to change it if they want you to change it. There's a large number of Agile methods. In other words, Agile is not a particular method, it's just a general concept. Okay. Agile methods. Plan-driven development evolved to support the engineering of large, long lifetime systems such as aircraft control systems, where teams may be geographically dispersed and work on several years. So this is plan-driven development. What does that remind you of? Plan-driven development? That's the initiation document. That's what that's the waterfall. In other words, you first come up with a whole plan, and then you have a huge team, and you work on it. This is based on controlled and rigorous software development processes that include detailed project planning, requirement specifications, and analysis system modeling. However, plan-driven development involves significant overheads. It may cost Boeing a lot of money to design the software for their new plane. It may take them 5 years to design it. If after 4 years the company decide that it's already out of date, you know what I mean? It's already, there's newer planes and nobody wants this kind of a plane. So they just throw everything away. However, plan-driven development involves significant overhead and documentation. It does not support, in other words, you have to pay a lot of money and you have to hire a staff before you have anything that you could sell. Agile methods were developed in the 90s to address this problem. These methods focus on software rather than its documentation. In other words, we're not going to write so much documentation. We're going to just try to make some software. Develop software in a series of increments that aim to reduce process bureaucracy. Actually, big companies like IBM, they sometimes have a special division which is run outside of the company. It's like its own little company. And because they need to have a small group to work in an Agile way. The Agile Manifesto. We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value the following things. Individuals and interactions over processes and tools. In other words, make sure that you have good individuals, that they know how to communicate with each other, rather than using set in stone processes. Like first you have to fill out this form, and then you have to send this form to this person, and he has to sign it. You know, instead of having processes, have good communication. Working software over comprehensive documentation. In other words, don't spend years writing comprehensive documentation before, and then who knows if the software actually does what the documentation said it's supposed to do. Better to have working software. Customer collaboration over contract negotiations. In other words, basically tell the customer, let's not negotiate over every detail of how you want this thing. Let's develop a good relationship between ourselves and we'll work together as we develop this product. We'll show you what we've got, you'll tell us how to change it. There'll be a lot of communication with the customer, as opposed to like two lawyers sitting in a room and coming up with the whole contract and then we have to do according to the contract. Responding to change over following a plan. In other words, we're more interested in responding to changes that the customer may give us or that we may discover than following plan. Right, halfway through the project, we may realize that we've got to change things. So we have to expect that. While there is value on the items on the right side, we value the items on the left side more. Okay.
What's left and right?
Of this is like, you know, these four things are left and right. Customer collaboration is more important than contract negotiation. Okay, both are important, but we're more interested in the left-hand things. In this table, could have been right, but that's it. All agile methods are based around incremental development and delivery. That's what we've been saying. You make a little improvement and you already deliver it. You already give it to the guy to use. Product development focuses on software features, where a feature does something for the user software, right? We have a concept called features. You're all familiar with that term. So for us, what it means is a particular functionality that the software can do that is actually desired by the user. There's a concept, I don't know if we talked about it here, called feature creep. You ever hear of feature creep? It's not a guy who likes features too much, which you could think. Where were we? I don't know if it's here. Feature creep, you should know, is that as you add features, because you're working incrementally, you can incrementally add features, software features. And you may, at a certain point, start to have so many features that you can't see the trees for the forest, something like that. You don't even know what are the main features of this software anymore. Because you have so many features, they've creeped in. You sort of like creeped in many, many features. Oh, I want to be able to do this, I want to be able to do that. So somebody coming to the software will already get confused by too many features. So you usually have a person whose job is called the product manager, not the project manager, the product manager, or the product person, I don't know. And his or her job is to have a vision for what the software should and shouldn't do. And when you come to a new feature, you may say, no, I don't want that feature. That's a different product. In other words, you don't want in your banking software to also have a feature that you can play music, right? You could, why not? Maybe everybody wants to play music while they're filling in those checks.
They would stop putting on hold within the app.
So you don't have extra features that are not relevant to the task at hand. But sometimes it happens gradually. So that's called feature creep. It creeps up on you.
Like
Creep,
CRE.
like an animal, like a small lizard creeps up on you and you didn't notice that he came there. And then all of a sudden you got a lizard in your bed.
Wonderful.
So that's called feature creep, that the features creep up on you and you have too many. So sometimes the product manager will say, if you want that feature, remove this feature. I don't want too many features. And also he wants to make sure the features fit the vision of what the product is. It's like if you ever, it's like if you ever wonder, like why doesn't Citibank also sell pizza? They're interested in making money and they can make money making pizza. So let them make pizza. And you know what? Let them make cars too. So there's a vision for this company. No, we're in the banking business. We are not going to do everything, even though we could make money at that, and maybe we're interested in making money. So you sort of limit your vision. Sometimes companies do what's called pivoting. You haven't heard that term. Pivoting is an important term also. If you have a company that will change, it realizes that it starts making pizza in addition to doing
Like
banking.
Domino's.
Yeah.
Domino's used to be Domino's Pizza, now it's just Domino's and they do other stuff now.
Okay, yeah. No, well, I was thinking even worse than that. Like, imagine if Domino's Pizza would start selling ice cream, and they find out that they're actually losing money on the pizza, and the ice cream are making money on.
Well,
So
like
they may just
Tesla, they started with like whatever, just their cars, now they're doing spaceships and.
no. But I want to say, let me get to the point. So they stopped making pizza, and now they become Domino's ice cream, and they're not interested in pizza anymore because they're just losing money on it. So that would be called a pivot, in the sense that you not just added to some other job, but you mamish changed what you're doing. You're no longer selling pizza, you're selling ice cream because you found that it's more beneficial to you. So a software company may find they're not getting investors, and they're not getting clients. So they just change what their product does, and they make a new product. With incremental development, you start by prioritizing the features. This is an important point also. The most important features are implemented first. In other words, you say my software can do A, B. I want that, my vision is that my product will do A, B, and C. But the main thing that I want to do, the thing I think is going to attract customers to me is C. So I'm going to do C first, and I'm going to develop that, and I'm already going to sell the product as just being able to do C. And later I'll add A and B. That's called the important features you implement first, and you already get it out there. Of course, it's not going to work on an airplane, right? If you're doing a computer to run an F-16 fighter plane, you're not going to say, well, the most important thing is that it should fly. So you're going to make the whole software and put it in planes, and then fly, but it can't land or something. Good thing. It has to be able to do a certain set of features that make it usable, and also in a plane, you may not want to do it features because nobody wants to fly the plane unless it can do a whole lot of features. And you're not going to want to start ripping out machine, because usually, by the way, the software in a F-16 is probably not like you start up the computer and it uploads. It's probably hardwired into it. Yeah, go ahead.
I just have a question on what you said before about the initiation document. So you said that that's used with the waterfall approach, right?
Yes.
But I thought that there was a part in our initiation document that we had to discuss if we were using waterfall or agile.
Really?
No.
Really? I didn't know a paragraph about why we're using agile.
Oh yeah.
Don't do that.
I really think that there was a.
There may be a thing where it says what methods of development you'll use.
Oh, and then I just
You
interpreted that.
interpret that.
So if I wrote it using agile.
You could. Don't worry about it. Okay.
You guys all read it, so it's fine.
You only define the details of the feature being implemented in a particular increment. In other words, this 2 weeks, we're going to do this feature, and we're going to define what that feature is for the next 2 weeks, and we're going to finish it in 2 weeks. That feature is then implemented and delivered. Users or surrogate users can try it out to provide feedback. So you can have certain people in your company who are pretend users who then try, which we would call QA, quality assurance.
And this is different from beta testing?
Wait a second. Beta testing, beta testing? First of all, there's alpha testing and there's beta testing, not just beta testing. Even though it's like there's C++ and there's C, but there's no C+. Some people think there might have been a C+, and then there's C++. But there was a B, there was a language called B, but there was no language called A. You know the history of that?
We have
Someone told us,
Yeah,
in
C. But I guess we'll
But I
forget
didn't pay attention.
There was a language called B named after Bell Labs. It was developed at Bell Labs in New Jersey. And they called the language B for Bell Labs. And then they improved it and called it C. And then C++ was the improvement on that.
Why was in this past?
Because C++ is because there's a command in C called plus plus. So it's like saying one more. So they just call it C++, as opposed to calling it D. You only define, okay, so we have surrogate users who try out and give us feedback.
But you didn't answer my question. Is this like
Oh,
beta
beta
testing?
testing. Beta testing
What's
is,
beta testing?
what is beta testing? Beta testing is when you have a beta version of the software that is basically, the company says like this, we are not quite ready to really release it and say this is a working, but we think it basically works, but we haven't tested it. But we're going to release it to people who want to use it early, but they should know that there may be bugs with it, and they're supposed to tell us, they're supposed to report back to us what bugs they found.
So they use other people to basically do the debugging.
Exactly. So they're using their quality assurance. Let's call it debugging. It's rather debugging is actually a process as a programmer does to find the bug once. See, there's two things. Debugging is removing the bug from the software. Finding the bug is a different job. Finding the bug is you don't need much training for that at all. You just need to use the software and say, hey, when I put in my credit card and then I make a mistake and I change the last digit and then I remove it, then all of a sudden it doesn't let me go through. You know what I mean? When I do a certain set of procedures, then the software stops working. That's quality assurance. And beta testing is just like people who agree to do that for free.
So like QA is in-house and beta testing is out-house?
WhatsApp Web, the most recent thing, it said beta on the top left for the new update for a bit until now. It's like if you update again, now it's
Right, so it means it's still, beta means it's still in beta testing. Alpha testing would be in-house, really.
And
This is talking in much more general terms. He's not specifying any particular one. He's just saying users or surrogates. In other words, users would be beta testing, surrogates would be in-house people, and that would be QA, can provide feedback. You then go on to define, in other words, once you've figured out that it works, you go on to define and implement the next feature. Okay, so incremental development looks like this. Okay, guys, we have a product feature list. In other words, remember I said the guy who's the product manager has a vision of A, B, and C is what you're gonna do. So we choose the feature to be included in this increment. The product guy says, I want you to do C. So then we refine the feature description. We're gonna do C. All right, let's talk about C. Exactly how should it work? Because we gotta get clarity on this if we're gonna actually do it. Then we implement and test the feature. We make it and test it and it works. Then that's just sort of, then we integrate the feature into the system. We see that our new feature doesn't cause any other feature to stop working, for example. It has the integration testing. First thing is this testing of the actual thing. Does the feature work? But then maybe we got to retest everything else. Maybe it broke something. Maybe your feature broke something. Now we've shown that it increments, that it integrates with the other features properly. And now we can deliver the system increment. If all features are complete, so if we have all the features that we want for this release, then release it. If not, choose another feature from the list. Even if we did release it, we may have more features to it, so we choose another. So that's why it's a circle. We're going around and we're all the time choosing another product feature to implement. So now we're going to actually explain all these things we just explained. Choose the feature, use the list of features in the planned product. Select those features that can be implemented in the next product increment. You can think about what features you might want to do. You might say, do the easiest ones first. Probably the idea really is to do the most, the feature that has the most other features dependent upon. No, the most basic feature. Refine the feature. Add details to the feature description so that the team have common understanding of each feature. There's sufficient detail to begin implementation. Implement the feature and develop automated tests for the feature. Automated tests. So you a lot of times are going to have automated tests. In fact, that's a whole field that companies don't have enough automated tests. They have a staff of QA who follow a handwritten document that says test this, test that, test this, test that. And they go through it and they check. This worked, this worked, this worked, this didn't work. And they follow, because you want the same tests over and over again. Every time you change something, you want to run all the old tests and see that they work. So this becomes very labor intensive. So you want to have automated tests for your software. You'll have other software that will run tests on your software to see if it does A, B, and C, and D. Integrate feature and test. Integrate the feature and then test it. Integrate the developed feature with the existing test to check that it works in conjunction, no, it didn't break anything. Delivery increment. So if there's enough features to make a new release, then release it. Involve the customer. So here's some principles that we said. Involve the customers. I like cold.
I don't. You said you like cold?
I like cold.
Okay, great.
I was enjoying this whole week has been great. It's cold nights. That's
It's cooling off at night.
I feel like I get, what?
Cooling off at night, yes. Being cold?
Oh no, I don't like to be cold. I like cool air. I like to be warm and have cool air. Anyway, involve customers closely with the software development team. This is also totally different. At Boeing, I always take Boeing because they're a huge company. At Boeing, they have their software people, and they may be like, we don't want like people from the Department of Defense sitting around our offices all the time, looking over our shoulder. We want to work on our own. So no, we say no. If you're working for a small startup or a company that makes a certain feature, it's probably a good idea to call up, let's say a medical equipment. A lot of times a medical equipment software company will have a doctor on the staff who has experience with using this machine and says this is a good feature, it's not a good feature. This feature works the way I want it to or not. You need a consultant like that. So, but it could be an actual customer, the actual person who's paying. Their role is to provide and prioritize the new system requirements and to evaluate each increment of the system. Is this a feature that I want, or is this a useless feature? Embrace change. Embrace change. In other words, don't say I got a plan and I want to stick to the plan. No. Say, I have a plan, but I'm going to embrace any changes that come up. I'd be happy to do. Expect the features of the product and the details of the features to change as the development team and the product manager learn more about it. Adapt the software to cope with changes as they are made. In other words, the software ideally would be built in a way that you could change it as you find out that you didn't understand the problem properly. A lot of times you have that. The software person thinks he understood the problem, starts working, and he actually didn't understand the problem. Develop and deliver incrementally. Well, we understand that. Maintain simplicity. Focus on simplicity of both software being developed and in the development process. Wherever possible, do what you can to eliminate complexity from the system. Focus on people, not things. Trust the development team and do not expect everyone to always do the development process the same way. Team members should be left to develop in their own ways of working without being limited with their respective software processes. In other words, don't have strict rules that, you can't have a class that's more than 4 functions. Or, you know what I mean?
When we end up having very messy stuff to work with, like if you've got 6 people working on development on software, and everyone's doing their own way, and then you're going in, this code's like inconsistent and different styles.
You're right. It is. That's why there are rules. But this is saying we're going to focus not on those rules, but more on the people. But you're right. There was a need for, because they had people doing things in very different ways, people came up with rules for how to do it. And this is saying, well, let's go back again. Let's trust our programmers more. In other words, it's a balance. Sometimes we say, no, we need rules. We never follow. So now we're saying, well, put a little bit more emphasis on trusting them and letting them have a little bit more freedom. And you say, well, they're going to cause problems. You're right. One thing is done is like this, is that you'll have a lead programmer. And he will sort of verbally tell you, I want, do things like this. Don't have functions with more than 4 parameters. We're using classes. He'll tell you guidelines. So, but not so strict. That's my point. I mean, without an example, it's hard to see. But apparently, in the past, there were strict rules about how to program. And it depends on the companies. At a company like Amdocs, in the past, I know. Amdocs is a big company, and they take in programmers without much experience, and then they train them to work in their way. In other words, they have a strict set of how to write code, how to do things, and they may teach you for 2 months before you even start doing anything productive, how they want you to program. And then you work for them, and then you only do it their way. And that's a problem, actually, because if you work there, then you only know how to program in Amdocs style programming, and you may not be able to work at any other company. So if you do work at Amdocs, don't stay there for more than a year or 2.
Good to know.
And what?
I said good to know.
Yes, good to know. In general, big companies that train you a lot, that invest a lot in you, that's because they want you to work in a certain way.
But if smaller companies take that approach, then it doesn't matter if you come with your previous ways. Like not every company.
Yeah, but you may not know. You may be. The point is like this: the Amdocs way may be outdated. It may be 20 years old. They've been teaching everybody to work this way for 20 years, and they never changed it.
They need to change it though. Actually, anyone in high tech would change the way they work.
No. It's a big pain. You have a system, you have all the documentation, everybody's working that way. In fact, there was I don't know if it's still true, but it was true up until, maybe it's still true, that they wanted programs to know COBOL. which is like one of the earliest
Does
languages.
anybody use that anymore?
So that was the point. Even today, you can research it, but they still want people to do COBOL. Why?
Amdocs does?
What?
Amdocs does?
No, banks and stuff. Maybe even Amdocs. But because why? Because they have code that's running all kinds of very basic stuff in COBOL, and they don't. And they'd rather just, improve that code than scrap it all. So they keep, they're maintaining old code. My point is that big companies do not update the ways of working. There was something called extreme programming. I don't think you hear about it much anymore. It was kind of, but actually it's really because it's kind of been adopted by everybody. I think it's actually very much connected with Agile. Extreme programming, the most influential work has been to change software development, was the extreme programming, otherwise called
Oh, it
XP.
still happened.
What?
That was what the,
No, it wasn't.
yeah, never mind.
The
And
name
I
was
made those
coined by
myself.
Kent Beck in 1998, not so long ago. The approach was developed by pushing recognized good practice such as iterative development to extreme levels. What we're talking about now is iterative development. Extreme programming focused on 12 new development techniques that were geared to rapid incremental development, change, and delivery. Some of these techniques are now widely used. Others have been less popular. In other words, the catchphrase extreme programming is no longer in vogue, but that's just because we've really already adopted it. It's already become normal. So we don't have a term for it anymore.
What does it mean practically? Like, this is
Well,
where
we're gonna
you're
talk
at,
about what it
like,
is.
Extreme level, what does it mean?
So we'll see. The most widely used extreme techniques highlighted in red on the following slides are explained elsewhere in the book. So
Extreme programming.
So here's some examples of extreme programming. Extreme programming practices. So here you see it says all these things are part of it. Small releases, well, we saw that. Refactoring. There's this concept called refactoring. I think we're going to talk about that more. I don't know. Test first development. This you may have done in another course. I don't know.
Is that like test-driven development?
Yeah, it's like test-driven development.
Yeah,
Exactly.
we use that in a project in software engineering.
Which is a brilliant idea, which is that you write the tests for your software before you write the
That's what
software.
we're doing now.
And then you just write the software, and as long as it passes the test, then it works.
Well, why not write the exact same test after you write the software?
Because I'll tell you why. Because the fact that you've written it will bias the way you write the test. In other words, you want to break your thinking. You want first,
But just you
Be
written
clear.
also bias your coding of the development, because you're gonna try to.
But that's what you.
yeah, but you're doing that before you got involved in the deep intricacies of the program. You're just saying, well, what is the you should show your test to the
It's
to the
a
product.
very comprehensive test, it's like every single case.
Yes, every
And
single.
then once you try to make it work with everything, that's.
Right, you're right, but at the first level, presumably when you started writing the program, you knew what you were trying to do. Sometimes after 2 weeks of working on it, you lost track of what you were trying to do because you've been working on it for 2 weeks. So at the beginning, let's write the test, and you still have knowing what you're doing. Furthermore, that test, you should get like a list of the things that are supposed to test from the product manager or from whoever decided on this feature. Continuous integration, well, that's kind of what we discussed up to now also, that you're integrating new features all the time. I don't know exactly what the difference between small releases and continuous integration. It's kind of the same thing. Incremental planning. Right, you don't plan the vision of your software right now. I mean, just think about like Word. Word existed 30 years ago, but it's had new features. Did they think of all those features at the time they first developed it? No. So this is saying recognize that. Recognize the fact that you're not going to write the perfect software. You're going to write some features. Collective ownership. I think what collective ownership means that there's not just one person who you're writing for. Think about all the people who are going to use your software. Sustainable pace. I guess don't try to do too much too fast. On-site customer. Well, that I talked about. Have somebody from the clients in your offices testing it with you. Pair programming, I'm not sure what that is. And simple design.
Pair programming is if you have Like instead of like splitting things up, saying you do this, I do this, you sit, like, you do it together, that we have more than one
Oh, right,
person.
yeah, we're gonna talk about that, yeah. Right, I'm not sure I agree with this, but there's a line here in the book that says that it's sometimes better to have like two people sitting together at one computer writing code.
That's what they want us to do for our project.
Yeah, most of these.
It's good if the other person you're with is very good and you're very bad, so that's good for you. You learn from him. But usually what happens is that one person becomes dominant. One person actually is doing it. The other person is sort of, the other person will try to give advice. I think you should do like this, I think you should do like that, and the other person, it could be good. It can be good, because sometimes.
Unless you take turns who's doing the program.
Yeah, I think, right, exactly. If you take turns, that could be better. I'll tell you the advantage of it could be like this, that when you're involved in like saying, which should be an equal sign or a plus equal sign, and you're getting involved in all the details, you need a person who's not doing that, who's just thinking, he's in a different mode of thought, where he's just brainstorming.
I feel like it works best for concepts. Like you said initially, a plan like the logic out together. That's incredibly helpful. But like when you're programming, like what's the benefit?
Well, because as you're doing it, he may get stuck as you're programming. Say, wait a second, how am I going to do that? And he's too caught up in the details, and you're a little bit out of it. You say, I know how you can do it like this, And then he'll say, no, you can't do it like that because blah blah blah. And then you'll think of another idea. But you need one person who's like, it's kind of like you're building a brick wall. You need one person who's dealing with the cement and putting the bricks, and another person to look at it and say, wait a second, it's not really straight. We better move some bricks over here. But he needs to step back. What?
Yeah, the guy who's sitting there telling you like how you didn't do good.
He's annoying. Yeah, okay. So now we're going to go through a bunch of these things. You see all these things here? We're going to have a paragraph about each of them. Incremental planning, user stories. So there is no grand plan for the system. You're not going to say, this is how Word is going to work and it's never going to change in the next 30 years. Instead, what needs to be implemented, the requirements in each increment are established in discussions with the customer representative. In other words, we tell the customer, we know you have a grand vision, but what do you want the first version to do? What's your minimum feature list for the first release? And we get him to already cut down a lot of features. The requirements are written up as user stories. This is a concept we're going to come back to. A user story is like a story of how I use the software. The stories to be included in a release are determined by the time available and their relative priority. In other words, if we have to release something within 2 weeks, we maybe only do 1 or 2 stories. Small releases. The minimal useful set of functionality that provides the business value is developed first. That's what I just said. You ask him, what's the minimum features that you need to actually have something useful? Releases of the system are frequent, incrementally functional development. Test-driven. Oh, here we go. Test first. See, here he called it test first development. Here he calls it test-driven. So that we know. Developers write the test first. This helps clarify what the code should actually do, and then it's always tested. We'll never have code that's not tested. An automated unit test framework is used to run the test. Also, we're going to have automated. I mean, when you're doing test-driven, then you also obviously are going to have automated tests, and then that means your testing process will be faster. New code should not break the code that is already used. In other words, you're going to run all the old tests on any new development. Continues as soon as the work on a task is completed, it is integrated into the whole system, and the new version of the system is created. In other words, the way you work actually at a company is like this. You have, let's say, a release, and then you released it, and that's version 6. So now that's the version for release. Then you copy that version into a development server, and then everybody is changing that version 6. So it becomes 6.1, 6.11, 6.12, and everybody is adding another function, another thing. When it's finally tested and it works, we release it as version 7. But in the meantime, we're all integrating into this version 6, all of our changes, and I see your changes. So in other words, if I add a feature and then and then you want to come along, you'll see my feature already. You won't be working on version 6. It's not like you have a clean version of the last release and you just add your stuff. It's that we're all working on we're all slowly building up the version 6. We're all adding to version 6. So I see your changes, you see my changes. And what can happen is I add a feature and all of a sudden your feature doesn't work. In other words, I built a feature, but when I integrate it, this is with Git. You know Git?
Yeah.
This is how you do Git, how you add something to the Git repository. And now everybody sees it. When you were working on yourself, it may have worked, but in the meantime, there may have been changes to the version. When you integrate it, you may have conflicts. You learned about like conflict resolution in Git? Merge, yeah, but then, yeah. Merge.
We also like rebase.
Okay, refactoring means improving the structure, readability, efficiency, and security of a program. All developers are expected to refactor the code as soon as potential code improvements are found. This keeps the code simple and maintainable. This is actually was a test question last year, which was, what is refactoring? And they gave a bunch of sentences and you had to choose the best one. And what's not here on this list is making the program more efficient. That's not part of refactoring.
It says efficiency of a program, right there.
Where?
It says
Oh, efficiency. Oh,
And we'll give them all extra marks.
well, actually, I had a discussion with one of the students about it. I told him if he did the error, I would give it to him. But the official, then I looked it up actually online, on Google. I didn't remember this here. I guess that's why I thought efficiency was. When he first asked me, I said, sure, efficiency is part of refactoring. Then I looked it up online and they said, no, that's not refactoring. That's efficient. That's making it more efficient. That's a different thing. Refactoring just says, make the structure, instead of having like, you may have like one function calls another function calls another function, it may turn out that you can combine two of those functions into one. That would
But
be,
that is more efficient.
no, efficient, no, So that may be what they mean by efficient. If you call that being more efficient, then it is correct. What we mean by efficiency is like this. Let's say I have a bubble sort, and I say, wait a second, I don't need to do it. If I notice that it's all sorted already, then I'll quit my loops, right? You know that idea in bubble sort? Yeah. If you detect that if you didn't do a single swap, if you went through a whole inner loop and you never did a swap, then what do you know? It's in order already, it's sorted. So you got a flag that tells me, did swap or didn't do swap? And if it remains that didn't do swap, then I can end the whole loop early. Is that adding complexity or removing complexity? That's adding complexity. Is it making it more efficient? It's making it faster. If that's what you call efficiency, it's faster. But that's not refactoring. You see what I mean? Changing the logic, Sheva, changing the logic to make it run faster is not called refactoring. That's the point. If I change the logic to make it run faster, that's not called refactoring. Refactoring is just rearranging the existing code in a way that's more readable, in a way that makes more sense, but not more efficient in the sense that my code will run faster. You see what I mean? In fact, it may actually run slower after the refactoring. The goal of refactoring is clarity, usually. Clarity, that it should be clear what I'm trying to do, that the code should be maintainable. Simple and maintainable, you see, that's the goal. The goal of refactoring is to keep the code simple and maintainable, not to make it run faster. That was the question.
So efficiency here.
Efficiency might mean efficiency in the sense of visual efficiency. In other words, it looks better. You don't seem to have extra code. It also may improve, well, that's usually security. Okay. So now let's talk about Scrum. Have you heard of Scrum? Yeah?
In the beginning.
Yes.
From me or from another class?
I think in intro to software engineering we did.
Yeah. So let's talk about Scrum. So Scrum is actually, I think Scrum is actually a term from like rugby, where you like, what is this supposed to?
It's when they will get together.
Before they start?
It's a huddle.
It's a huddle before.
No,
it's part of the game.
Oh, it's part of the
They
game.
throw the ball and then they scrum.
It's scrum. You put the ball in the middle and the two teams like put
Shoulders
like
to
a tower.
shoulders to
Why?
And they push the balls in the middle.
Why does one of them just grab it?
Whichever side man tries to push it over,
Can't
that's
wait
the
till
point.
gets the ball to begin with.
Football. and
Oh,
everything.
that's how you start?
Yeah.
Football like that.
Oh,
Okay.
So Scrum, so in that sense, so let's think about that. So in that sense, Scrum is like a communal activity that you do to get the game started.
Yeah.
Right?
Yeah.
So that's exactly what this is. That's what Scrum is. It's a communal activity that we do to, it's usually something called a Scrum meeting, and there's someone called a Scrum Master. A Scrum meeting is in the morning where everybody gets together, and it could be once a week, but I think officially it should be every day. You get together and everybody says what tasks they're going to do. You ever see the boards things?
You mentioned.
I mentioned before.
Your Post-its on the wall.
Exactly. So you have these everybody gets together and we say we need to get these 6 things done today. Who's going to do what thing number 1? Who's going to do thing number 2? And everybody sort of agrees, and they also say what they did last week. Yesterday I finished this thing. I didn't finish that thing. I'm still working on that thing.
Sounds good.
What?
They call it a scrum, so we have a scrum.
Sounds embarrassing, yeah.
Yeah.
Software company managers.
No, it's like, I guess like the board of the.
So I love this.
It just sounds
Like,
so
here's what I
smooth.
wasn't able to accomplish in the last week.
It sounds so prep school-y. Everyone come out to the class and introduce what you've been
No, I think
doing
it
for the
sounds like
past week.
Well, what it does is it creates
Pressure.
pressure.
Update everyone up to.
It creates pressure, but it also creates a set of personal responsibility. I committed to doing this thing. If I see everybody else, taking 2 tasks and I didn't take any yet, I'll take. And I think when I take 1 task, I may feel guilty, and I'll take 2. So it's pressure. But also, I obligate myself. As opposed to my manager telling me I want you to do this and this and this, I actually obligate myself. So then,
And you can do things that you think you're good at and are interested in.
exactly. You can also. That's a good way of looking at it. If you're confident in your abilities, then you'll choose the thing that you won't say I'll choose the easy thing. You say I choose the thing that I want to do, and you say it's great. I don't have my manager telling me what to do. I'll choose, and you may be the first one to choose because you want to be sure to get that one because you want to do that one. So that's the idea of a Scrum meeting, and it's mature. It promotes maturity in your step, as opposed to I can't believe my manager gave me this job and I have to do it, and I'm disgruntled because he gave me a job I don't want. Here, I chose what I want to do. I mean, this is what has to be done. These are the things that have to be done in the company. What do you do? None of them? We have to, this is our company. But here I like this first line because what he says is software company managers need information. So managers, they need to be able to make reports and write up things. So they need information. They need to know what people are doing. If the manager doesn't know what anybody's doing, then he can't manage. So he wants information. So how he wants people to tell him how long will it take. In other words, he wants to be able to go back to the big manager and say, this guy's gonna, because actually not only do you take it, you say how long you're gonna take to do it. You say, I think I can get it done in a half a day. I think I can get it done in 2 days. You say, and therefore the manager says, go back to the bigger manager and says, all right, my team says they can get all these features done in 4 days. Maybe, let's say they're wrong, it'll take 5 days. So he can give sort of information to his other boss. Plan-driven development provides this information through, so if you're doing waterfall, then you have a waterfall plan that gives you milestones and dates, and you don't have to have a Scrum meeting. You know that on January 5th, this is what's going to be done. You have it all planned out. Remember we did that with the cost analysis, where we say remember how many man months and we know exactly how many months and how long each part is going to take. But plans always change in reality. So really only short-term plans are reliable. Scrum is an agile method that provides a framework for an agile project organization and planning. It does not mandate any specific technical practices. So again, I said the technical practices to use these post-it notes, but he's saying it's just a concept. The concept is that we have some kind of meeting, we make plans in some way for a short-term feature creation. Oh, now we're going to talk about the product, which is what I was mentioning before. We have the product, the software product that is being developed in the Scrum team. The product owner, which I sometimes call the product manager. I've been called the product manager. He calls it the product owner. Let's say that's interchangeable. A team member who is responsible for identifying product features and attributes. They review work done and help test the product. In other words, they're the person who says this is a feature, this is not a feature. I don't want my F-16 fighter plane to also be able to tell me, you know, to compute algebraic equations. That's not what it's built for. I don't know, whatever. Product backlog. There's something called a product backlog, which is a to-do list of items such as bugs, features, all the things that the Scrum team have not yet completed that will be on those Post-it notes. In other words, one of the Post-it notes might be the QA team has found a bug in this feature. Who's going to fix it? So fixing a bug might be. So generally, who would fix that thing? Who would you say would fix it?
Just some guy who wrote that.
The guy who wrote it. The engineer who wrote that bug last week could probably be the one to say, but theoretically not. You could have a team where there's a guy who loves doing debugging and he'll debug other people's code. Whatever, there's no rule. But there's also in this to-do list are features, right? All the features. And that's called a backlog. Development team is a small self-organizing team. That's what I actually like that about it. I worked in this system. And if it's self-organizing means you don't have a manager. There is no manager. Because it's kind of belittling. You know, you're an adult and you have some other person who could be even younger than you and less experienced than you as your manager. So why should I have a manager? We're adults. We can decide what we're going to do, and we'll tell you. I'm going to do this, and it's going to take me this long. So there may be a person who reports back to the upper level management, but there may anyway, self-organizing team. So there's 5 to 8 people who are responsible for developing the product. Sprint, another major concept. What a sprint is. A sprint is, we're all in Scrum terminology. The product owner or manager, the backlog, the development team is the team of people, and the sprint itself is the short period of time, 2 to 4 weeks, when a product increment is developed. I used to think that a sprint was like, we're working slowly, and now all of a sudden we're gonna do a sprint so we can get a feature out. That's what we did in my company. But a lot of companies don't work like that. And what do? They do sprint 1 is week 1 to 3. You know, the first half of the month, the first 2 weeks of the month, we're going to do sprint 1. The second 2 weeks, we're sprint 2. Next month, we're going to do there's no time between sprints. You just go from sprint to sprint to sprint. There's no jogging. It's just sprinting all the time.
It sounds like that's not sustainable.
That's why in my company, we didn't do it that way. In my company, we sort of would like have slow working periods and then a sprint. But it's kind of stupid.
Keeps things fresh also, sprint. Like you're never working on something for more than a month, let's say.
Well, the main thing about a sprint, it's 2 weeks, 1 to 2 weeks. The main thing about a sprint is it's definitely not a month. It's really not a month. A month is too long.
It says 2 to 4 weeks.
It does say that, but okay.
How could, yeah, that seems like so short.
A week.
They contribute.
I'd say it's for like a big
Okay,
update.
I'll take what it says in the slide, 2 to 4 weeks. But still, a month is as long as the longest it should be. In my company, it was a lot of times 2 weeks. But we wouldn't necessarily have every 2 weeks another sprint. But my wife's company, they do her old company, they would do a sprint every 2 weeks.
But don't you get burned out?
So the idea is that like this, if you can't, you're working all the time. It's not like you're trying to do it fast. It's like we have a deadline. You said that you took that feature off the wall and you said you're going to finish it in we have 15 features here. And each one is going to take 2 days. So that's, and we have 4 people. So we'll figure out it's a week. It's a week's worth of work on the board there. So let's give ourselves a deadline. We're going to, but actually that's not the way, those are the features that we need to get us, those are the things we need to get done to release a certain feature. So we're going to say that feature is going to come out in a week. Now, if it turns out that we can't get it done in the deadline that we set for ourselves, we may actually we may say, okay, we're going to skip over one of those things there on the board. We're not going to get rid of that bug because we need to get it. So it gives you a sort of feeling of accomplishment. You're going to, come hell or high water, you're going to finish this feature at that time. And then and it may mean that you'll have to remove certain things from the description in order to get it done. That's a last resort. But the point is, it gives you a sense of satisfaction. After 2 weeks, you got it done. You did something. Now you can all have a office meeting. You can have cake, and then do the next thing. And then you're back to planning. And the planning might be a week. It might be a day. You might spend a day thinking about what's the next feature going to be, discussing it, and then you all agree on what the next feature is going to be. And now we'll set the next sprint. There might be some time in between. But the point is, you go from a sprint. There's no such thing as like working slowly. It's just working in a sprint. question is, which sprint are you? It's called a sprint because you're trying to get to a certain target. Anyway, so Scrum is the daily meeting, and the Scrum Master is a team coach who guides the team in the efficient use of Scrum. I don't know if it's really that he guides the team. Scrum Master is just the person who says, okay, we're having the Scrum now, and says, okay, who's taking, he's the one who just runs the meeting. Who's taking this feature? It's just the one who prevents it from just being people walking around and just doing stuff. Like, in other words, it's somebody who puts some organization on that meeting. That's all. I don't know if he has to actually be a coach. My wife was actually a Scrum Master. She was the Scrum Master just because she would prevent people from chit-chatting, or wasting time. She was very tachlis. Okay, potentially shippable product increments. So that's the point. The output of, this is an important sentence also, the output of a sprint, which should be of high enough quality to be deployed for customer use. In other words, a sprint, what defines a sprint? It's that I'm producing something that is shippable, that I can actually deliver. I'm not just doing a sprint to take out some bug. I mean, whatever. Well, if take out a bug, could be. Now I have a new version of it, bug-free version. So now I'm going to ship that. Point is, I'm producing something that I actually will be able to ship. Velocity. And that's sort of how much work a team can do in a single sprint. So the velocity is saying, in this sprint, how many features can we get done? 2, 3. Okay. Key roles in Scrum. So here we're again talking about the product owner. Remember we mentioned this product owner? So here, product owner is responsible for ensuring that the development team are always focused on the product they are building rather than diverted to technically interesting but less relevant work. In other words, somebody may say, it would be very interesting if I could do a certain thing. And he may say, I want to figure out a new algorithm for sorting. We say, well, whatever, Python has a built-in sort function. Just use that. Don't waste your time on your interesting ideas. In product development, the product manager should normally take on the product owner role. So sometimes the product manager can be the product owner. In my company, it's very small. We didn't have a right. See, how they call it product manager, product owner. It's the same thing. I don't know why. Right. The product manager is the product owner. That's what he's just admitting that now. Fine. The Scrum Master, we said already, the Scrum Master is the coach, is an expert whose job is to guide the team in the effective use of the Scrum method. The developers of the Scrum emphasize that the Scrum Master is not a conventional product manager, but is a coach for the team. They have authority within the team on how the Scrum is used. They're not really a manager. They're just saying, all right, we're going to have a Scrum on twice, every day or once every 2 days. He's in charge of the Scrum. In many companies use Scrum. The Scrum Master also has some product management responsibilities. Fine. Scrum and sprints. In Scrum, software is developed in sprints, 2 to 4 weeks. During a sprint, the team has daily meetings to review the progress and update the list of work items that are incomplete. We already understood that. Sprints should produce shippable product. He's repeating himself. This means the development software should be complete. Okay. So here we see the life cycle. Review product backlog. Remember the backlog? What's the backlog?
The to-do list.
The to-do list, exactly. Select items to implement. Now, they're not going to do everything on the to-do list. The to-do list may be a year's worth of work. And who's going to put things on the to-do list, perhaps? Who should be putting things on the to-do list?
The manager.
The manager, not necessarily the Scrum leader, the manager, yes. Who's going to choose the ones to do in this sprint?
The Scrum.
No.
The people, guys.
It could be yes, but which particular guy of those guys? So you said the manager who's he's going to put the things here. I would say like this, the product owner is going to choose the things to do this feature. These are the product owner, the product manager. There's the product manager, not the group manager.
Oh.
He may say, I want these features to be, forget it. My question was a bad question. Either person could choose, but some manager is going to decide, these are the things we're going to release in this feature. Select items to implement. Plan the sprint. In other words, which means who's going to do what? I'm going to do this, you're going to do that, and she's going to do that. Now do the sprint. Now we did the sprint. This is obviously gonna take the most time. And then we review the sprint. We say, okay, what went right and what went wrong? Who, what didn't get done? Maybe something didn't get done. Maybe it was bigger than we thought. What feature, maybe we were gonna do 6 features, but maybe one of those features was just no good. Why did we think it was doable and then it turned out not to be doable? Anyway, this is the ship. When the sprint is over, we have a shippable product. And what's over here? The backlog.
Is the backlog like if something isn't done by the time the sprint is over?
No, I think this is just saying what's happening during the sprint. I'm not sure exactly why it's called sprint backlog. This circle seems to be when you're in the sprint, what are you doing? Every morning you're having a scrum, you're developing some software, you're testing the software, and then you're scrumming again. Each day you're doing, you're scrumming, you're developing software, and you're testing the software. And that's your sprint. This may last 2 weeks. And then finally the sprint is over and you go to here. That's the way I see it. Yeah, that makes sense? Why exactly it's called a sprint backlog? I guess the things, because this is all the backlog. This is all of the things, I understand. This is all of the things that the product may ever want to have in. This is the subset of that, which is what particular things have been selected for this sprint. Is that clear? Okay. Top 5 benefits of using Scrum. The product is broken down into a set of understandable chunks that stakeholders can relate to. In other words, clients or managers or anybody can understand what we're doing today, what we're doing this week. Unstable requirements do not hold up progress. What do you mean by unstable requirements?
Over-promising.
What?
Over-promising to do something we want.
Yeah, unstable. What do you think unstable means? I think it means like we're not even sure what the requirement is. He maybe changed his mind every couple of days, so we're going to leave that one for later, and we're going to do other ones. I think that's what it might be. Unstable requirements. I'm not sure. Unstable features. I'm not sure. Trust between customer and developers is established, and a positive culture is created because they're seeing stuff coming. Everyone's working together. The team communication is improved because everyone can see everything. As everyone knows, as opposed to a manager just coming over to my cubicle and saying, you do this and this and this, and I have no idea what anybody else on the team is doing. We have a scrum meeting every morning. I see the whole picture, and I see what my role is in that picture. It's much more, you don't feel like a cog in a big machine. You feel like you see the purpose of what you're doing because you see it in the whole team. Customers see on-time delivery of increments and gain feedback on, right, if you just keep saying, don't worry, it'll be ready in a year, don't worry, it'll be ready in a year, don't worry, it'll be ready in a year, and then the year comes and says, oh, okay, it's gonna take us another 2 months, they get very frustrated with you. But if they say, well, if they're with you all along, then they can't really complain. They got one feature, then a week later, 2 weeks later, they got another feature, and it turns out actually that it took a year and a half when they thought it was gonna take a year. But they knew that they were with you in that slowdown. They know that it's like if you tell your spouse you're gonna clean the floor, and then you tell them in the middle of the day, oh, the kid came home with dirty clothes and I had to wash them, and then tell them, and then my boss called me and said I need to write a letter. And if you inform your spouse all throughout the day, all the things, then when your spouse comes home and you didn't do the floor, they won't even ask you why you didn't do it. They'll know already. Just an
Tell them buying
Yes.
software engineering.
It's a strategy. It's
Tell them buying advanced.
yes, exactly.
It's the same concept.
Shalom bias, advice from software engineering. Yes.
Someone you have to plan your life. Same thing.
What?
It's like
Planning.
It's the same concept. Planning still makes you done. We have to do it.
Exactly. You're working as opposed to just because that's what's good about WhatsApp actually, because you can all the time send them like Like if I get like if somebody wants to come for Shabbat or something, or I get invited for Shabbat or something, I just forward the message to my wife and say, I received this from Gabriel, and then it's not like me requesting anything. I'm just spreading information, and so now we can, she can react the same way I can react. I find it's always better. In fact, I did this once with there's another couple that we used to do things with, and I made a group in WhatsApp of the four of us. So I wanted to invite, because a lot of times happen, I would invite the husband for Shabbat, and then he would forget to tell his wife, and then so I just made a group. So I'll just send to both of them, but it didn't actually work that well because neither one would answer me then.
They both think the other one would answer.
Yeah, something like that.
Or they
There's a
talk
rule.
to each
There's
other
a rule.
Responding because you can't see each other's response and realize you responded differently.
What? Also, that's also
What's
true.
the rule?
That's also true. If they have to talk to each other before they can respond. They can't say, well, I'd like to come, I'll ask the other person. That you can respond immediately. But you could say that in the WhatsApp actually. I'd like to come. I don't know if Raphael wants to come. So no, the rule is like this in group messages. Never expect a response from a group message. If you send to your 4 friends an email that says, when should we have the birthday party? Which day of the week can people come? You're not going to get any response from anybody. So what's the correct? This is my life experience. So then don't ever do that. But no, you do that. What's the point of that? Is to just get the information out.
Yeah.
So you send them. I'd like to have a birthday party for Shoshana, next week. What day is good for you? Then you have to 2 days later write to each one of them individually. Which day is good for you for the Shoshana? And they already understand that there's a meeting. You already broached the subject, but you have to write them individually. You can get the information out, but then the actual response you have to write individually. That's the same in a company. If you want to write to your team something, who's doing this job? Nobody's going to respond. So you have to say, start going to each one of them. Are you going to do it? Are you? Anyway, that's the rule. The rule is messages are to do not expect a response, but you still can do those things. Team communication, because everyone can see what everyone else is doing. Customers see on-time delivery there. They feel good about themselves. They feel good about you. Key Scrum practices, product backlog. So now we're just reviewing, right? The product backlog is a to-do list of items to be implemented ever that is reviewed and updated before each sprint. In other words, we may add things to it as the years go, as the weeks go on. We may remove things from it as we implement things or as the product manager decides that this is no longer a feature we want to do. Time box sprints. Okay, we said that. Self-organizing teams, we said that. Discussing issues and making decisions by consensus. This I first heard from my cousin like many, many years ago, where she was doing a protest on the streets. And she said her organization ran by consensus, not by vote. Now, there's a concept of democracy, right? The majority decides. But you can't do that when you have if I don't want to do something, if there's 4 people in the team and one person is dead against it, then you can't really do it. You can say, well, 3 of us want to do it, so you have to do it. It has to be consensus. Otherwise, he's not going to work well. You have to convince him. Product backlog. So we said this already. The product backlog is a list of what needs to be done to complete the development of the product. Remember I said the product backlog is the big backlog. Items on this list are called product backlog items, PBIs. The product backlog may include a variety of different items such as product features, user requests, essential development activities. I would say deep bugging, also bug fixing, desirable engineering improvements. That maybe falls into the category. In other words, get something to work faster. The product backlog should always be prioritized so that items that be implemented first are at the top. In other words, priority is what to do first, not necessarily what's more important or what's easier. Example of a product backlog issue. As a teacher, I want to be able to configure a group of tools that are available to do classes, a feature. As a parent, I want to be able to review my child's work and assessments that are made by the teachers. As imagine some kind of software for teachers to put homework assignments and students to do them and parents to look at them. As a teacher of young children, I want a pictorial interface for children with limited reading ability. Establish criteria for the assessment of open source software that might be used as a basis, there's established criteria for assessment of open source software that can be used. In other words, we may want to take open source free software for parts of our program. So that's a development activity. Refactor user interface code to improve understandability and performance. In other words, maybe make the GUI, the graphical user interface, more easy to use. That would be refactoring, but it's an engineering improvement. Implement encryption for all personal user data. Okay. So those would be items in the product backlog. These are different things. There are different types of things that all need to be done by some worker. Ready for, so here are categories. Ready for consideration. These are high-level ideas and feature descriptions that will be considered for inclusion in the product. They are tentative, so may radically change, or may not be included in the final product. So ready for consideration is like, maybe our F-16 fighter should be able to play MP3 music, for the pilot to listen to when he's flying. The team has ready for refinement. The team has agreed that this is an important item and should be implemented. So it's already considered, past consideration, it's now ready for refinement. So you have to decide exactly how we're going to do it. There is a reasonable, clear definition of what is required. However, work needs to understand and refine the item. Ready for implementation. The PBI has enough detail for the team to estimate the effort involved and to actually implement it. So ready for refinement means now we're going to refine it. So these are three states that a particular feature could be in when it's in the backlog, right? It's in the backlog, but it could be in one of these things. So here's our product backlog. It goes through it can go through revised product backlog. So it goes through refinement. It can go through, what is estimation? Prioritization, we understand. Creation is, I don't know, these are stage, I'm not sure what that is. Oh, here we're going to say. Product refinement. Existing PBIs are analyzed and refined to create more detailed estimation. The team estimate the amount of work. Our estimation is how long is it going to take. Refinement is make sure it's well done. Make sure we know exactly what we're doing. This is how long it's going to take. Creation. New items are added to the back. These new features suggested by the product manager require feature changes to engineering improvements that might be used.
1:30.
What?
Yes, 1:30.
Oh, time is over or a break?
No,
break.
Break. Okay, break.
This was that one, 2.5 hours.
And it's from
Half hour to
12
to 2:45 with a half hour break.
How much more of this?
so it's 1 hour and 25.
Yeah, we're really diving deep into. It's funny, he spends a lot of time saying how Scrum is just one way of doing Agile. But then in the end, he only talks about that.
He only talks
Well,
about that.
Yeah, he doesn't talk about any other way.
Let's you know that.
What?
Government agent is stupid.
When do you go flying?
After my bed.
And how long? When 2 months? And you'll come back in time? Or you're finished?
Well, no, I'm not finished, unfortunately. Basically, I can't fly back between the end of support and the start of semester because it's like I'm out on Wednesday or something.
Mhm.
So I'll have to wait till the weekend after, which means which is when the semester starts. I'll probably miss like the first week of school.